Thank you to Lewis Sumner 8156 for the thumbnail inspiration for this video. If you would like your ideas to be the next thumbnail, please write them in the comments, because not only can I not be bothered to plan these videos anymore, I also can't be bothered to make the thumbnails either. You guys can just do that as well. Let's pick a random number, so 1 to 750, 750 roughly, generates, and we'll do number 381. That sounds very close to something we've already done on this series here, but it is different. Good. So it's some weird integral that looks like that. So let's get this bad boy typed in. So we're going to do the integral of, and I already can't remember what it is. Was it the, no, it was 1 over the root or something. So 1 over, ooh, keyboard's not working there, square root of, now what on earth was going in this root here? 8 to the power, x to the power 3 over 2 plus 4x is a weird, it's a weird integral that PowerPoint doesn't really appreciate me typing in. Let me just double check that we've got that. Okay, cool. Now, what on earth is going on here? Now, I mean, the first idea is to maybe take out an x here and write something like this. So you know, maybe factorize out a root x like this. Because we could maybe think about, I don't even know what we could think about doing here. This is a crazy integral. What is going on? I mean, you could think about some kind of partial fractions here, but the roots get in the way. You could try eliminating the roots, I guess. I don't know how that would be helpful though. Like if you times top and bottom by that root, you'd end up with obviously something that looks like this. I don't know how this will be helpful either. Well, then you could factorize. Is this helpful? Then you could factorize this. You could do this business on top instead, I guess. I don't know. Is this helpful? So, like, okay, so I've times top and bottom, and now I'm going to replace the top with this here. Now, this bottom you can just factorize out a full x from. I think, are we just getting to where we did before? I'm not sure. Who knows? So, okay, so that's that. And now we can do some cancelling, I guess. So this goes away here. I guess I've just done from here. I've just times, yeah. Okay, so we went around in a circle and we got here. And I still don't know how this is helpful. Because, well, or do I? Is this now substitutable, I guess? Like, is this, what if we used u equals, I mean, the thing to try would surely be x to the power half plus 4, I would have thought. Because that makes x to the power half here just u minus 4, which I think is manageable. So that's fine. It obviously makes this u. So this is all partial fractionable. And it makes the top of this root u, like this. And now the moment of truth is what happens to this dx. Does that make this in any way doable for me? So du is obviously a half x minus half, and this goes away, dx. And then if we times everything by 2x to the half, we end up with dx is 2x to the half du. So is this helpful? So that goes in here. And then I'm just thinking, is there some cancelling? Oh my gosh, this has turned out, unless I've made a horrible mistake, has this turned out beautifully? This is just u minus 4, no? And so cancels, bring the 2 out. This is just the integral of 2 root u over u, which is 1 over root u, which is u to the power minus a half. I'm probably just going to check this because that's worked out sort of almost too well. I don't quite believe it. So I times by the root. Oh, I've got rid of so much working that it's hard to see. So okay, let's go from here. I factorized out the x to the half. Oh, I don't even remember what I did. It's hard to see. You can play the video back. I think that it might be right. I guess we could get to the answer and differentiate it to find out. Who knows? Anyway, the integral of this is obviously half. No, it's not. I'm an idiot. It's 2 u to the half. So 2u to the half here. And then, of course, we can put the, we can say that's 4u to the half. And we can put the u to the, so it's 4. And then u to the half is root. It's just root of this, isn't it? So it's root of x to the power half plus 4. Now this seems ridiculously untrue as the answer to this question, because, or does it? Is this just some horrendously overcomplicated way of writing the derivative of this? Should we double check this somehow? So this is a weird one. It's one of those integrals where it's so easy to lose so much confidence in yourself. But I mean, the easiest way to check whether this is right is to differentiate it, right? So you can say this is this to the power half, just because then it makes more sense to differentiate it how it looks. And then, of course, okay, so the half comes down, makes it a 2. The derivative of this is a half x to the minus half, so that all the 4 essentially differentiates away, and you're just left with x to the power minus a half here. Obviously, the 4 differentiates away as well. And then you put a minus here. Now, what is this other than just 1 over both of those things? But like, when you do that, you realize you're going to get to the answer pretty quickly here, because when we do this and we do this, and then you can write, like, because they're both to the power half, you can write them, you can times them together, all to the power half, which is the root, and these two things times together to make this. This is definitely correct. This is the answer. Kind of weird. I completely lost confidence in myself and just stopped and was like, that's definitely not right. And I couldn't find the working, so I stopped and watched it through again to see where I could find the mistake, and I couldn't. But this is definitely right. I'll try and make the working. I'll try and not delete as much stuff for the next one, because otherwise I'm going to make the same problem again. Anyway, let's do another one. So let's do another one. 52. Okay, I actually didn't do the first 100 in the first couple of videos, and I forgot to change it. I'm assuming that this one's probably not going to be that bad. If it's very quick, we'll do a third as well. So let me just delete all of this stuff here, and then I've forgotten what it is. 1 over cos squared tan squared. Okay, so that's fine. This is already typed. 1 over cos squared tan squared. So immediately what I'm thinking is that tan squared is sine squared over cos squared, and the cos squareds cancel away, so this just makes sine squared, which of course is the integral of cosec squared. Now, I believe that because tan, oh, PowerPoint doesn't like look right in cosec anyway, tan differentiates to sec squared, which makes me think that I think cot differentiates to minus cosec squared, and so I think this integral is just minus cot of x. And in fact, I'm going to stick to my guns there and just say that that's correct. I'm not even going to test it. Or should I at least, what I'll do is I'll just look it up. A level formula sheet, there it is. So formula book. So F integral, let's go further down. No, it'll be in the differentiation, won't it? Will it? The differentiation of, I guess I'm looking for the differentiation of cot. Is that what I'm looking for? This is more effort than I really wanted to go through. Why are you giving me more? Is differential of cot regular A? No, not the integral. Is minus cosec, right? So yeah, I'm correct. Good. So that's all fine. Good. So that's that on. Next one then. We've got time for 3, so we'll do a third. Okay. Okay. I mean, right. Yeah. Next one is going to be what I literally almost said out loud, what are the chances of that? I'm a maths YouTuber. It's 1 in 750, mate. You absolute muppet. 468 though. Let's actually do this one and see what happens. Oh, that was a funny moment. Okay, so this integral immediately looks much worse and much more interesting. So let's break this out here. Apologies for flicking back to and from screens here. Cube root, I'm going to have to do this a few times because that is not easy to remember. So we've got the cube root of, now what on earth are we cube rooting here? 3 sine 2x. Oh, the font's been completely messed up. Okay, well, we can just make that bigger later. 3 sine 2x minus 2 sine 3x, I think, is what that said. Okay, cos x. Ooh. What on earth are you doing, PowerPoint? Okay. Okay. I don't think I'm going to be able to do any better than that without changing some settings that I can't always change. Let's just leave it. Okay, what is going on here? Um, I have no idea. Initial thoughts, let's make this 6 sine x cos x because it might be, and let's actually type stuff properly because that will speed us up. Because then we can factorize out a cos x. Now, how on earth that's helpful, I don't know. This sine 3x surely needs changing. The problem is that I can't remember the formula for sine 3x. I don't really want to have to bust it out if I don't have to. Alternatively, I could not do the full formula for sine 3x, but I could write it in terms of sine 2x and see what happens. Let's leave this here for a second and remember that we could theoretically factorize out cos x if we wanted to here. Now sine 3x is sine x, if I put this in brackets, I guess, is sine x cos 2x plus sine 2x cos x. Okay, just using sine a plus b plus sine whatever. So, okay, so does this help in any way? If we expand this out, we're going to get a cos x here as well. So that's interesting because that gives me sine 2x cos 2x here. So that's cool. And it gives me a cos squared x here. So let's get rid of this cos x now. But we can also expand out the 2, I guess, because we probably should have done that. So the 2 can go here, and the 2 can go here. Now, like I said, I've now created myself a 2 sine x cos x, which, as we know, is sine 2x. So that's kind of cool. And over here, is there something interesting I can do over here? Well, look at this now. We've got loads of sine 2x's bumbling around. We've got a cos squared here, which I think I could write as cos. No, I couldn't. How do I write cos? What's the useful way of writing cos squared that actually gets rid of maybe if I just get rid of this because I'm thinking about this again. So, oh no, I don't want to think about that. I want to get rid of this. I want to leave this as the cos squared that it was before. Yeah, I think I want to leave it like this. So, is there some useful way? I mean, they've all got sine 2x's. I could just factorize that out. Yeah, I think the next step is to think about this cos squared x. So, cos squared x is minus sine squared x. Now, there's no sine squared x's, which is disappointing, but maybe they'll come about later. That's cos 2x, right? I think. Not sure why these fonts are so annoying. PowerPoint just does this sometimes. Don't want to do that. Cool. Now, of course, that's 1 minus sine squared. So I think I want to write this. How do I want to write this to be useful? I want to write it in terms of, yeah, well, obviously I don't want this. So this is 1 minus cos squared. So this is 2 minus 1. I could just remember this result, but I just can't be bothered. So I always just derive it like that. So cos squared is, and I'll go back to here now. Cos squared is, cos is a half, which is useful, cancels that too. Maybe useful, maybe not, is cos 2x plus 1. Okay, now that's interesting because, of course, that guy cancels with that guy. Ooh, and then you just end up with a plus, so this just ends up being 4. That's just that, right? Is that just the whole thing? Oh, I said that I wouldn't delete working. So let's just do this again. So let's claim that this makes this, and then let's check the working. Okay, so we said that sine 3x was this. I believe that's correct. Then we multiplied out with this cos here. This should be a minus. Nice. So this should be a minus, which makes this not as good. It makes this a actually, it makes it good in the sense that it cancels the sine 2x. So that's interesting. So we end up with the cube root of minus, I think, 2 sine 2x cos 2x. Is that right? Again, let me just have a quick look through. This turned out to be unnecessary, so I'm going to just get rid of it. Cos squared was cos 2x plus 1 halved, which cancels this one here. This guy cancels this guy, and then we end up with 2 minuses here. It's interesting that so much of this... Did I copy down the question right? I'm just going to double check that I copied down the question right. Always a good double check. Okay. So I think I'm happy with this. Now, on the basis that sine 2x, I'll just put it down somewhere, sine 2x equals 2 sine x cos x. We've used this already in this question. Okay, so PowerPoint is just completely breaking down. That's fine. Just ignore the fact that x looks weird. On that basis, sine 4x is 2 sine 2x or x, because like the rule is the double angle rule. As long as this angle is double, those ones, this rule holds. So I believe this is the integral of the cube root of minus, I don't even need the 2 anymore, sine 4x. So, okay. Is this... I mean, the question is, this looks so much simpler, right? Like it looks like it should be fine. But the problem is, do I really know how to integrate that? Like what would be helpful is if I had some causes over here, because that's what this derives to. But I don't, so that's irritating. What is this rule that I've written down? Um, Hang on, go backwards for a second. Go backwards for a second. No, this was right? Yeah, no, this is fine. Yeah, we had that all correct. Um, so let's go forwards again. Oh, I can't go forwards anymore. Can I go forwards? Nope. Okay. So what did we decide this was? Sine 4x. And we were trying to work out why or how this is in any way helpful. Because I don't know how to integrate roots of sines if they're on their own, do I? I don't think I do. Um, I mean, certainly not cube roots of them. Like that's like what is... That's weird. I don't know how to make any more progress here. Um, I'll think about it for a couple of seconds before just deciding to leave it to you guys to finish up. I don't know how to finish this, I don't think. I don't think a T formula would work. I busted out T formulas to finish last video. The reason I don't think it would work is this cube root thing is, I think, just going to mess me up. I just think that's just not going to be very good at all. Um, so, yeah. Am I just being dumb? Can I just not think of the thing that you do here? Or maybe I've made a mistake through that whole thing. Maybe we just gone in the wrong direction entirely. Maybe this whole idea was just not the correct thing to do. It's also possible, which would be really disappointing because it seemed like it was going really well. Um, but that's just how it goes sometimes, right? That's just how it goes sometimes. Where did this 3 go? Let me just have a look at this again. Where did this 3 go? Where did this 2 go? Have I just completely confused myself with this working? What? I must have done some deleting and then... Hang on, no. This 2 safely went, because that's 2 sine x cos x, this time 2x. That 3 shouldn't have disappeared. Right, here we are. This must be it now. Because that actually makes it 2 sine 2x. Right, so we get to here. So I think that's this. Now the question is this helpful in any way? I don't know where this 3 went. I must have just made a mistake somehow. So I think this is now fine. So let's get rid of this and come back to here and think about this some more then. So always checking over your work, always like I just said in the previous question up here, leave your work nice and settled that way. Don't delete it that way. I guess if you're working on paper, you can't, but that way you can check your work. So, okay, let's have a think about this now. We can obviously factorize out sine 2x. I don't think that would be helpful. Or would it? This cube root, man, this cube root is still, I just don't know how to get rid of it. I just don't know what it's going to do. It's just very frustrating. Could we now go all the way down to x's and see if that helps? Because I know the double angle formulas. I don't think it would help, but let's just see whether it does. So this is sine x cos x with a 4 here. And this is, again, with a 4 here, sine x cos x. Is that where the rooting comes in? Could you, if you factorize out a sine 2x and then write it as 2 sine x cos x, does cube rooting that in some way help? I don't think so. And then cos 2x we've already decided is cos squared minus sine squared. I don't know how that's helpful. It's interesting that those two things. Yeah, so this is 2 sine 2x into 1 minus cos 2x, but 1 minus cos 2x, is 1 minus cos 2x a thing that's helpful? Is it not like sine squared? Because from here you can write 1 minus 2 sine squared is cos 2x. So therefore cos 2x minus, sorry, 1 minus cos 2x is 2 sine squared. That might be helpful. So what I'm saying here, going back a second, I know I'm jumping all over the place, but if you factorize out that 1, if you factorize out 2 sine 2x, you get this. And then that's, oh, this is so close to being helpful. 1 minus cos 2x from here is 2 sine squared. Problem is you can't quite combine those things because like you've almost got 3 sines, right? Which would cube root really nicely, but it doesn't quite work because this 2 here. But maybe it does work because now we can say sine 2x is 2 sine squared cos squared. So now we can maybe write this as 4 sine x. In fact, I'll make an 8 here. Now 8 is good because of course 8 cube roots to 2. So I think this all turns out to be this. I think. Now this, for the first time, this actually looks like something good. Because now if we go to the next page, I'll delete all of this. Now if we finally go to the next page, and apologies for this taking so long, but okay, I mean, this is just 2 sine x. And then we can, because we can essentially cube root, it's not cube root, we can essentially cube root the bit that can be cube rooted. Oh, PowerPoint letting me down again. Come on, there we are. So, okay, you can break this into cube root of these 2 bits times the cube root of that, which is, of course, the cube root of 8 sine cubed is this. Technically, I need some bars here, but I don't really care anymore. Of course, cos x cube rooted is cos x to the power of 1/3. And this is finally where this goes right, because this is just finally, I believe, some inverse chain rule, in the sense that because here is the derivative of this guy, if I just add a 1 to this, and then divide by 4/3, so it's the same as timesing by 3/4, so 6 is that 3/2 or something. And then I think I probably need a minus because cos differentiates to the wrong thing. I think this is the answer here. Times this by 4/3, it cancels to make a 2. Cos differentiates to minus sine, put that there, cancel the minus. And I think that's my answer. And I hope that I've got that right. Who knows? Thank you for watching. Bit of a more stressful one this time, but I think it was fine. I think it went okay in the end.